Hello everyone. Today we are going to look at the operators in Java. Based on the feedback received and considering repetition, from this video onwards, 2-minute summary will not be available in the remaining Java tutorial series videos. What are operators in Java? Operators in Java are the symbols that are used for performing operations. These symbols are used for performing operation on variables and values. Example, plus, minus, equal to, multiplication, etc. Note, Java does not support operator overloading. Types of operators. There are many types of operators in Java. They are unary operators, arithmetic operators, shift operators, relational operators, bitwise operators, logical operators, ternary operator, and assignment operators. Some consider instance of comparison as a separate operator, while others consider it as a relational operator. I prefer to consider it as a relational operator. Let's look at each of these operators in detail. Unary operators. Operators with only one operand are called unary operators. In Java, we can classify unary operator further into postfix and prefix. Postfix operators are post increment and post decrement. Syntax for post increment is expression followed by two plus symbols, and post decrement is expression followed by two minus symbols. On postfix operator, value is used for computing the result and then incremented or decremented. So in the example, during the computation, the value 10 will be used, then incremented. On the next line of code, the value will be 11. Prefix operators are pre-increment, pre-decrement, unary plus, unary minus, bitwise complement, and logical NOT. On pre-increment, the value will be first incremented and then the result is used for computation. Similarly, on pre-decrement, value is first decremented and then the result is used for the computation. Unary plus indicates the positive value. However, the numbers are positive without this. It performs automatic conversion to int when the type of its operand is byte, character, or short. Unary minus is used for indicating negative values. Bitwise complement operator returns the ones complement representation of the input value, that is, with all bits inverted. Logical NOT is used for inverting a Boolean value. Arithmetic operators. Arithmetic operators are used to perform simple arithmetic operation, basic mathematical operations like addition, multiplications. Can classify arithmetic operators into multiplicative and additive operators. Multiplicative operators are multiplication asterisk symbol, division slash symbol, and modulo percentage symbol. Additive operators are addition plus symbol, subtraction minus symbol. The addition plus symbol is also used to perform concatenation of string variables. You might have seen me using plus symbol on many occasions to combine two strings on example section of many videos. Shift operators. Shift operators are used to shift the bits of a number left or right, thereby multiplying or dividing the number by 2. They can be used when we have to multiply or divide a number by 2. Left shift operator shifts the bits of the number to the left and fills 0 on voids left as a result. Similar effect as multiplying the number with some power of 2. Example, signed right shift operator shifts the bit of the number to the right and fills 0 on voids left as a result. The leftmost bit depends on the sign of the initial number. Similar effect of dividing the number with some power of 2. Example, unsigned right shift shifts the bits of the number to the right and fills 0 on voids left as a result. The leftmost bit is set to 0. Example, relational operators. Relational operators are used to compare or check the equality. They return Boolean results true or false after the comparison and are extensively used in control statements. We will look at control statements in detail on later videos. Less than operator returns true if the left hand side is less than the right hand side. Greater than operator returns true if the left hand side is greater than the right hand side. Less than or equal to operator returns true if the left hand side is lesser than or equal to the right hand side. Greater than or equal to returns true if the left hand side is greater than or equal to the right hand side. Instance of this operator is used for type checking. It can be used to verify if an object is an instance of a class, a subclass, or an interface. Double equal to operator returns true if the left hand side is equal to the right hand side. Not equal to operator returns true if the left hand side is not equal to the right hand side. Bitwise operators. Bitwise operators are used to perform the manipulation of individual bits of a number. They can be used with any of the integer types. In performing update and query operations of the binary indexed trees, these operators are utilized. Bitwise AND operator copies a bit to the left if it exists in both operands. Bitwise XOR operator copies the bit if it is set in one operand but not both. Bitwise OR operator copies a bit if it exists in either operand. Logical operators. Logical operators are used to perform a function similar to AND gate or OR gate in digital electronics. With logical AND operator, the second condition is not evaluated if the first one is false, and with the logical OR operator, if the first condition is true, the second condition is not evaluated. Logical AND operator returns true when both conditions are true. Logical OR operator returns true if at least one condition is true. Ternary operator. The ternary operator, also called as conditional operator, is a shorthand version of the if-else statement. It has three operands and hence the name ternary. As you can see, the general syntax: condition followed by question mark executes the first part before the colon if the condition is true. If false, executes the second part after the colon. Example: assignment operators. Assignment operator is used to assign value to any variable. It has right to left associativity, that is, value given on the right side of the operand is assigned to the variable on the left. Therefore, right hand side value must be declared before using it or should be constant. Equal to operator. Simple assignment operator assigns value from the right hand side operands to the left hand side operand. Add assignment operator adds right operand to the left operand and assign the result to the left operand. Subtract assignment operator subtracts right operand from the left operand and assign the result to the left operand. Multiply assignment operator multiplies right operand with the left operand and assign the result to left operand. Similarly, for divide assignment operator, modulo assignment operator, bitwise AND assignment operator, bitwise XOR assignment operator, bitwise OR operator, left shift and assignment operator, signed right shift assignment operator, unsigned right shift assignment operator. Operator precedence. Precedence and associated rules are used when dealing with hybrid equation involving more than one type of operator. In such cases, these rules determine which part of the equation to consider first. As there are many different valuation for the same equation, this affects how an expression is evaluated. Certain operators have high precedence than others. For example, the multiplication operator has higher precedence than the addition operators. Say x is equal to 7 plus 3 into 2. Here, x is assigned a 13, not 20, because multiplication operator has higher precedence than addition operator. So, it first gets multiplied with 3 into 2, and then adds into 7. In this table, operators with highest precedence appear at the top of the table, those with the lowest appear at the bottom. You must ensure to remember operator precedence. Let's look at some examples to understand in detail. To explain unary operators, had created the class unary operators. Declared integer variables a is assigned with 10, b is 5, c is minus 10. A boolean variable d with the value as true. Printing a with the first unary operator post increment. It will first print the result and then increment the value. So 10 will be printed, but the value is incremented to 11 for the next line. In the next line, using pre-increment on a variable, already the value of a is 11. Because of pre-increment, it changes to 12 and then 12 is printed. Similar for post decrement. The value 5 will be printed first and then decremented to 4. Then again, here value of b will be 4, decremented to 3 and 3 will be printed. Then simply printing the unary plus. So a is currently 12, so it will simply print as 12. Since I am adding a minus sign with unary minus, it will print minus 12 here. The bitwise complement of negative number. So C is declared as minus 10 and I am using the bitwise complement operator to simply invert the bits. Here minus of total positive value which starts from 0, hence will be printed as 9. Then bitwise complement value for positive number A. The current value of A is 12. Positive of total minus where positive starts from 0. Hence minus 13 will be printed. Logical not, D is true. It will simply show the opposite boolean value which is false. Let's debug and check. So here the value for A 10 is printed. Now you guys can see the value of A is 11. Then it actually prints 12 with the pre-increment. Similarly, B value is 5. Now it is 4 and 3 will be printed. As you can see, the output is printed as expected. Now moving on to arithmetic operator. Have a class arithmetic operators, declared variables a and b. So here this one performs addition. Simply a is 10, b is 5, 10 plus 5, 15. Subtraction a is 10, b is 5, 10 minus 5, 5. Multiplication 10 into 5, 50. Division 10 divided by 5, 2. Then modulo operation 10 modulo 5 is 0. There is a final statement for printing the expression. Here, the operator precedence need to be considered when there are more than one operator is involved in any expression in Java. Here, because of the parenthesis, first a plus b will be calculated, then a minus b will be calculated. Finally, both will be multiplied and we will get the result 75. Let's check the output. The output is printed as expected. The next operator is shift operators. Declare the three variables a equal to 20, b equal to 2 and c is minus 20. For the left shift operator, a left shift of b, which translate to 20 into 2 power 2. So this is the value of b, this is a, and because of shift operator, everything is taken with 2's power. So the output is 20 into 4, 80. signed right shift. What will happen is instead of multiplication, it will simply use division. So 20 divided by 2 power 2 equal to 20 divided by 4, which is 5. The unsigned right shift operator for positive number works exactly the same as signed right shift operator. There is no difference. It will produce the same result. The only difference comes with the negative value. In case there is a negative operand is used on the left hand side, then the shift changes parity bit to 0. Hence, we will get a different result for this. Let's check the output. As you can see, the output is printed as expected, and the negative number unsigned right shift number we got as expected. Relational operators. So once again, we have three variables: a equal to 10, b equal to 5, c equal to 10. Simply we are printing the greater than, less than values. Here a is greater than b, which is actually true. A is less than b, false. A is greater than or equal to c. So a and c both are 10. In this case, it is true. A less than or equal to b, that is false. A equal to c, yes, a and c are equal, hence it will be true. A not equal to c, a and c are equal, hence false will be printed. There is one more relational operator which is instance of. To understand and how the instance of work, we had already seen couple of examples in the previous videos. Here just recollecting it, I created a sample parent class. There is a print method inside it. Have a sample child that extends a sample parent. Creating an object for sample child here and simply checking whether the sample child is an instance of sample parent. Since sample child object is an instance of sample parent class, this statement will be true. Let's execute and check the output. The output is printed as expected. Bitwise operators. Once again, the same set of variables. Now checking bitwise and or. Here, initially, I am trying to check with the Boolean condition. The bitwise and checks whether both these statements are true. If both the statements are true, then it will say true. If any one of the statement is false, then it will say false. Here, a less than b is false and a less than c is true. Since one of the statement is false, false will be printed. Bitwise or, if either one of the operand is true, then it will going to print true. So here a less than b is false, a less than c is true. Hence it will print true. Now we have seen bitwise operator is also used with along with integer, and it can be used to copy and shift bits. I am declaring two integer variable. As you have seen, you can define integer variable with binary notation. 0b indicates binary value. After that, I am specifying the bits. The D value is originally 60 and the E value is 13. When I use bitwise AND, the value is 12. When I use bitwise OR, it will be 61, and for a XOR, it will be 49. We also have another operator, bitwise operator, which is basically bitwise complement operator. We can utilize that on integers. Just to illustrate, the unary operator is also a bitwise operator. Let's execute and check the output. The output is printed as expected. Logical operators. Defining two Boolean variables x and y, x is true and y is false. Now simply using the logical AND operator. As you know, when both the statements are true, then only logical AND will say true. For OR operator, either one can be true, then it is true. For not, simply inverts the current Boolean value. You might wonder what is the difference between the logical AND and the bitwise AND. Let's look at each of them in detail. To illustrate the difference, here I have declared the variables. First, I am performing logical and then bitwise AND. So the main difference is, in case of logical AND, if the first statement is false, the second statement will not execute at all. Whereas in case of bitwise AND, it will execute both the statements and then determine the results. Both expressions are evaluated in case of bitwise and then printed. A is less than B, which is false. So, on logical AND, this expression will not execute at all. The value of A will remain as 10. Whereas, in case of bitwise AND, this is false, but it will still compute this expression. So, value will be incremented here to 11, and then it will check 11 is less than C, which is 20. 11 is less than 20. So it is true. Because of AND gate, one of the statement is false. Hence, the result will be false. Now, the result will be 11. The same difference, once again, if the first statement is true, the second expression won't be evaluated. Whereas, in case of bitwise OR, both the expressions will be calculated and then the gate will be applied. Let's execute and check the output. The output is printed as expected. Ternary operator. So ternary operator is a shorthand version of if-else statement. Here declaring A and B. The idea is to find the minimum and the maximum value among these two variables. So the first condition A less than B, ternary operator A B. How it evaluates is if A is less than B, then take the A value, else take the B value. Here 10 is less than 5, which is false. So B value is taken. The value will for minimum is 5. So the value for max variable will be 10. Let's check the output. The output is printed as expected. Assignment operators. The first one in the assignment operator is the equal to operator. Everywhere where we are assigning a value to a variable, we are using the equal to operator, which is the simplest and basic assignment operator. The next statement, a plus equal to 2, which translates to a equal to a plus 2. So the value will be 10 plus 2, 12. The value for a is 12. A minus equal to 3. 12 minus 3, 9. A into 5. 9 into 5 is 45. A divided equal to 3, which is a equal to a divided by 3. 45 divided by 3, 15. Similar for the model. Let's execute and check the output. The output is printed as expected. Skill check. After every topic, there will be set of questions with multiple choice options which you can use to self-check your skill on that topic. These are derived by me for the topic. You can find the answers in the video description. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question. Second question. Third question. Fourth question. Fifth question. Irrespective of the domain or the type, you will use various operators in any given Java project. In case you are unaware of what an operator does or the precedence of the operators in Java, there is a high potential of errors. The simplest things are often underlooked or ignored in programming, which would result in huge errors. While the operators in Java might look extremely simple and easy, if ignored and the programmer doesn't know what an operator does, it can result in huge issues. Knowing the purpose of each operator in Java and the operator precedence is essential for writing quality code. Thank you.